In this video, we're going to talk about geometric progression perpetuities and how they apply to pricing stocks. I'll step off camera here so you can get a chance to pause and write this down. All right, let's suppose that we have a perpetuity in this case that pays X at the end of the first period, and then after that we're going to increase, usually increase, but it could decrease by a certain percentage of each of the previous payments. So we're going to call that percentage change G. So each payment changes by that percentage over the preceding payment. So this is a lot like how we set up the geometric progression annuities. Looking at our time diagram, we said that X gets paid at the end of the first period. So we've got X at time 1. At time 2, so the end of the second period, we've increased the payment, or we've changed the payment by a factor of G. So we get X times 1 plus G. Third payment, we get X times 1 plus G squared. Similarly, up to the nth payment, we get X times 1 plus G to the n minus 1. Very, very, very similar to what we had for geometric progression annuities. Just with perpetuity, we know that we're going to continue these payments on forever. All right, we're interested in knowing what the present value of this perpetuity is. So if the period of effective interest rate is I, well, we're going to need to move all of these payments back to time 0. So X needs to get moved back one time period, so we have X times V. The X times the 1 plus G need to move back 2 time periods, so we get X times 1 plus G times V squared. All the way up to the nth payment is X times 1 plus G to the n minus 1, then times V to the n. And that's just like what we had for geometric progression annuities. It's just in this case, it's going to go on forever. So we're going to end up needing to sum up an infinite geometric series rather than that finite geometric sum. So, but same idea, same principles that we talked about before. Every one of these terms has a common factor of xv, so let's factor that out. Then we've got this geometric geometric series here, starting at 1 plus the 1 plus gv, the 1 plus gv squared, so on down the line. So we've got this common ratio between terms now of 1 plus g times v. So remembering our infinite geometric series formula, we know that the sum of that series will be 1 over 1 minus that common ratio, or the 1 over 1 minus 1 plus g times v. V is what it usually is, 1 over 1 plus I. So replacing each of the v's with 1 over 1 plus I, we get this expression here. Then if you multiply the 1 plus I through on the bottom and simplify, you'll get I minus g on bottom. So the present value of this perpetuity turns out to be X over I minus g. One thing that you should note is that in order for this even to make sense, our growth rate needs to be less than our interest rate, because otherwise, for this formula, you would have a negative here. But if you're growing faster than what the interest rate is, this would end up going off to infinity for the sum, for the present value. So in order for this model to, or this formula to make sense for the present value, you need to have the interest rate greater than your growth rate. So how does this apply to stock pricing? So there's a model for stock pricing that's referred to as the dividend discount model. So if you have a stock that pays dividends at the end of each period, whatever that period happens to be, maybe it pays quarterly, maybe it pays annually, whatever that happens to be, and the dividend is expected to grow for each period. So if G is our expected growth rate, then we can think of this idea for doing the dividends, we can think about doing the present value of the dividends in the exact same fashion that we just did for the perpetuity. So the dividend discount model says that the value of the stock, or the price of the stock today, should be the present value of those dividend payments. Of course, there's a couple of assumptions that go into this. Of course, you're assuming that the dividend increases by the same percentage each year, and of course, you're assuming that the dividends will be paid in perpetuity. We actually do have a perpetuity and not an annuity here. So, but it does give you a first taste of doing some stock pricing, and in the next video, we'll do an example for the pricing of a stock.